Good evening, everyone. Let's see the problem. A push down automation P transition of the form P goes to Q and P A comma X you will go to Y. Some transition like that, where P comma Q belongs to Q, A belongs to tau union epsilon, X comma Y belongs to epsilon, x comma y belongs to tau union epsilon. Consider the following. Means normal push down automata is given. This is the push down automata. One push down automata is given. See the push down automata. This is the diagram. Q0, Q1, Q2 and Q3. Q3 is the final state. Q0 is the starting state. And Q0 epsilon hash. On Q1 A comma epsilon A. On Q1 epsilon comma epsilon is epsilon. On Q2 B comma A is epsilon. On Q2 epsilon comma A goes to A. Right? One push down automata is given. Q3 is the final state. Q0 is the starting state. Then is asking the number of strings of length 100 accepted by the above push down automation is. In this push down automata, right? The number of strings of length 100 by the above push down automata is how many? And what is the alphabet given? Alphabet given is, right? Let me write now. Alphabet given is A comma B. Over the alphabet A comma B, 100 length strings are everywhere two possibilities. Everywhere two possibilities are there. Approximately, right? Two possibilities. The number of strings of length 100. Length 100, 2 into 2 into 100 times, approximately 2 power 100 strings are there. Out of them, the number of strings of length 100 accepted by above push down automata is. So out of 2 power 100 strings, how many strings are accepted by above push down automata? Can you check once? It is a very nice problem. Last year GATE exam or before year GATE exam, this question is given. Yeah, I have cold and cough. I have heavy cough. I hope I can do the justification to this class. Right? You can start. Right? You can start this. So in this PDA, 100 length strings, how many accepted? Can you check yourself? Can you try this? Is this PDA is visible to you? Check once. Is this PDA is visible to you? Yeah, let me go to that problem. I think below. This is the problem. This is a problem. So I will try to maximize a little more. I will do maximize. And now it's fine. Check. In this PDA, how many 100 length strings are accepted? In this PDA, how many 100 length strings are accepted? Check once. 100 length strings are actually 2 power 100. How many are accepted by this PDA? In one of the previous papers, this question is given. In one of the previous paper, this question is given. Can you try once? How many 100 length strings are accepted? I think if you observe clearly, right? This one on the Q0, epsilon comma epsilon, right? Hash. What is the meaning? Without reading anything, without seeing any top of the stack, simply push. What is the meaning? So this is the string. Assume this is the string. Without seeing the input string, without seeing the top of the stack, simply push hash symbol. That's the first. Okay, you push the hash symbol. That's fine. Now go to the Q1. On Q1 state, can you check now? Q1 state, one loop is there. What is the loop? On the Q1 state, A is coming. Top of the stack can be anything. Push A. A is coming, top of the stack can be anything, push capital A. Top of the, right, A is coming, top of the stack can be anything, push capital A. A is coming, top of the stack can be anything, push capital A. So like that, all A's you can push. Like that, all A's you can push. That is the purpose of this. First transition is push hash. Second one is on the Q1 loop. For every small a, push capital A. For every small a, push capital A. For every small a, push capital A, like that. So let us assume that so many A's are there. So many capital A's are pushed. Like that, it is keep on going. Now can you help after completion of this one, see this one. Epsilon, comma, epsilon, comma, epsilon. It is almost like first transition. What the meaning are we? Without seeing any input string, everyone listen. Without seeing any input string, without seeing top of the stack, right? Don't do anything. What the meaning? Don't read the input string. Don't see the top of the stack also. Don't do anything. This means don't do anything. Skip operation. Whatever, right? Don't see the input also. Don't see the top of the stack also. Right? Just don't do anything. Means without doing anything, going from one state to another state. It is almost like in the finite automata epsilon transition. It is almost like on Q1 epsilon, I will go to Q2. In the finite automata, this is the meaning. This is called null transition. What is the meaning? On the Q1, you didn't take any input. You didn't see in the top of the stack. You simply skipped it. So after taking all A's push inside the stack. Afterwards, simply skip the state without reading any input symbol. Simply skip the state. Afterwards, listen. Afterwards, B is coming. Top of the stack is A. Then pop. For every B, pop A. See, B coming. Top of the stack is A. Pop. For every B, pop A. For every B, pop A. Like that, it's keep on continue. When you are going like this one, for every B, pop A. When you are going like this one, what is happening? What is doing? You see this one. Nothing is coming. In the input, nothing is coming. But top of the stack is still A. Indication that input string is completed. See, nothing is coming means input string is completed. Still A is coming, top of the stack. Indication that in this particular, right, according to this PDA, listen. According to this PDA, first A's are coming. All A's are pushed. Next one, all A's are pushed. That's okay. Next one, B coming. For every B, pop A. All A's are pushed inside stack. For every B, pop A. 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 Like that it is going on. It's going. Now unfortunately string is over. Still A's are there. How many A's are there? I don't know. But still A's are there. So this language, if you observe clearly, A power M, B power N, where M is greater. It is almost like A power M, B power N, where M is greater than N. This language is almost like A power N, B power N, where M is greater than N. And one more thing if you want, you can observe. Some people are asking, sir, is it possible, right? Only A's possible. Let's check here. Only A's. Is it possible? Only A's. Let's see this one. Only A's push. Afterwards, directly epsilon is coming. Yeah, only A's also possible. Some people are asking, sir, only B is possible. No, because the top of the stack should be A. So that is the reason. Only A is possible, but only B is not possible. Only B is not possible. I think this is going to be, let me write now. M is greater than N. M is greater than N. Everyone listen. M is greater than N. And 100 A's are possible. Right? Let me write now. A's, B's. 100 A's possible. 0 B's possible. 99 A's possible. 1 B possible. And so on. Let me see this one. And so on. 51 A's possible. 49 B's possible. But 50-50 not possible. Check here. 50-50 not possible. It is not possible. Further not possible. 100 A's possible, 0 B's possible. 99 A's possible, 1 B possible. And so on. 51 A's possible, 49 B's possible. 50-50, no chance. I think if you observe clearly, 51 to 100, right? How many are there? Those many. I think 51 to 51, 52, 53, and so on 100. How many people are there? 51 to 100, you know, one array formula there. Last one minus first one plus 1. Right? 100 minus 51. How many? 100 minus 51, which will goes to 49. Plus 1, 50. 50. So I think 50. So 51 to 100, right? How many are there? 50 people. Answer is 50. Answer is 50. If anything wrong from my side, please take care. It is a nice question. It is a nice question. It is a nice problem. Answer is 50. These kind of things only will come. These kind of things only will come in the GATE exam. The number of strings of length 100 accepted by above PDA. Now in this problem maybe PDA given. Maybe he will give in the next year GATE examination. Maybe finite automata. Maybe Turing machine. Maybe 100 replaced by 50. 100 replaced by 75. Small changes he will do. But mostly this kind of thing expected. Mostly this kind of thing expected. Mostly this kind of thing expected. Please let me know if anyone having doubt. It is a very nice problem. It's a very nice problem. Please let me know. Anyone having any doubt? Same question can come in the exam. Same question. Just changing 100 by 50. Right? 100 by 50. 100 by 99. Small changes. Small changes. Yeah. Let's go to next problem. Let's go to next problem. Can you see this? Consider the grammar with non-terminals n is equal to S, C, S1, right? Some terminals are given, some variables are given with start symbol S and the following set of rules. Some rules are given. The grammar is not LL1 because, can you check yourself? Yeah, now see. Thank you, Varun. Thank you, Varun. So he is asking, listen, he is asking, the grammar is not LL1, what will be the reason? The above grammar is not LL1, what is the reason? He is saying not LL1. You no need to verify. You no need to verify, right? It is LL1 or not. He is already mentioned it is not LL1. What will be the reason? Can anyone check? It is a nice problem. Can you check once? This is not LL1. What will be the reason? Someone is saying C. Someone is saying it is ambiguous. If anyone say, some people are saying it is ambiguous. If anyone say it is ambiguous, can you give one string where multiple trees possible? Can you give one string where multiple trees possible? If anyone say it is not LL1 because of ambiguity, please let me know one string to which multiple trees possible. To which multiple parse trees possible. If it is not LL1, please give one example where multiple parse trees possible. Where multiple parse trees possible. Those people who are saying that it is ambiguous, can you give one string where multiple trees possible? And one small question I want to ask you. In this grammar, the grammar whatever is there, it is not LL1 means everyone know. It is not LL1 means maybe left recursion is the reason. No left recursion here. So it cannot be the answer. No left recursion. Right recursion and LL1 no relation. Next one, it is not context free. Right? Who said that if the given one is not context free? See this one. If it is not context free, who said that? Right? How the condition? Right? There is no relation at all. Right? Answer only option looking like is option C. But if you want to show it is ambiguous, you have to show one string where multiple trees possible, multiple parse trees possible. Can you show one string where multiple parse trees possible? If anyone knows, answer is option C. Answer is option C. But can you give one example where multiple parse trees possible? I will give the answer. First you try. Yeah, I am fine. I am fine. Vandita, I am fine. If anyone say it is ambiguous grammar, can you give one string where multiple parse trees possible? If anyone say it is not LL1, sorry, it is not ambiguous. If anyone say it is ambiguous, can you give one string? Answer is option C, ambiguous. If anyone say it is ambiguous grammar, can you give one string where multiple parse trees possible? Someone is saying that IBT, IBTA. Let's see this one. Someone is saying that IBT two times followed by A. Let's try this. Let's try. S goes to, listen, S goes to I, C means B, T, right? Afterwards, let me write now. Right? IBT, S1 there, S1, right? I want, right? IBT, A. Yeah, let's try this. So this S1 can I keep epsilon? This S1 can I keep epsilon? Right. So this S is replaced by, say, I think 5 people. IBT S1, IBT S1. So you got IBT, right? You got IBT, okay, but SS1 also there, but lastly you want A. Lastly you want A. If you want lastly A, I think this is the only way. A. Any other way? Someone is saying IBT, one parse tree I drawn. This S1 is anyhow epsilon. This S1 is anyhow epsilon. IBT, A. I got already one tree. IBT, I already got one tree. Can you give one more, right? One more tree. Is one more tree possible? Is one more tree possible? Can anyone guess? This is the ambiguous grammar. Can you give one string where multiple trees possible? It's a very, very famous grammar. It's a very, very famous grammar. This grammar is very, very famous grammar. Can anyone help me? If anyone say this is not LL1, sorry, this is not ambiguous. Sorry, this is not LL1. Reason is ambiguous. Because no other options are nowhere, no relation is there. With other options there is no relation. This grammar is not LL1 because with other options no relation. Only option is option C. Option C means ambiguous. If it is ambiguous, please show one string where multiple parse tree is possible. Please show one string where multiple parse tree is possible. Try once, you are very close. Please give one string where multiple parse tree is possible. Can anyone guess? Someone is saying that IBT AEA. See this one. Someone is mentioned IBT AEA. Let's check. Someone is mentioned IBT AEA. IBT AEA. IBT AEA. Now can I help you now? IBT AEA, S goes to IBT S dash. S1, that is fine, that's fine. Now see this one, right? So can anyone help me now? S replaced by, what is the answer? S replaced by, what is the answer? IBT, you want AK. S1 by ES. S1 by ES. This is S replaced by A. So where is the multiple trees? Where is the multiple trees? Where is the multiple trees? Yeah, I think now people came to the correct conclusion. See this one. I think this will be the answer. IBT AEA. AEA. Let's check here. IBT AEA. Everyone listen. IBT. Again IBT. Again IBT. Yes. S1. Now listen. Here two S1s are there. What you want? IBT AEA. So this is A, okay. S1 will give A. S1 will give E. Right? S1 will give. You can take from this also. Take from anyone. So if you take this one choice. If you take this one, another choice. I think here multiple trees possible. This is the example for this. Right? Remember, it's a very, very dangerous problem. This is called as a dangling else. Right? You see, it is something like this one. Dangling if and else. This is called a dangling if else problem. This is called dangling if else problem. What is the meaning? If condition, then statement, else statement. It is the dangling if else problem. It is the famous problem. Dangling if else problem is a ambiguous grammar. Dangling if else grammar is a ambiguous grammar. It is a one of the famous statement. Dangling if else grammar is a ambiguous grammar. Please remember. IBT AEA. Right? Because of this reason, so many strings may be there. One of the string is this one. IBT AEA is a ambiguous grammar. Some people are asking, sir, where is the ambiguity, sir? IBT, S replaced by IBT. Afterwards, A also came. You want EA. EA can come here. Listen everyone. Some people are asking, sir, how EA, sir? How EA? Let's check here. This is replaced by ES. S by A. This is epsilon. This is one way. Right? AEA. This is one way. One more way. S1 goes to epsilon, fine. But this S1 is replaced by, what is the answer? ES. Right? This S is A. This is one more way. So two parts is possible. IBT AEA. This is the famous computer science problem. Right? Dangling if else problem. Which is dangling if else grammar is ambiguous grammar. Dangling if else grammar is ambiguous grammar. Please remember this. Right? This is going to be if condition true. Let's see this one. If condition true, then statement yes. Else statement yes. Dangling if else. Grammar is ambiguous grammar. Example also given. This is one of the example, but many grammars may be there. Some people are asking, sir, in GATE examination, how I know, sir? Everyone know. Checking ambiguity is undecidable problem. Checking ambiguity of the given grammar is undecidable problem. It is difficult to you, for all the people difficult. But remember, next time onwards, dangling if else grammar will come. It is a ambiguous grammar. Remember this from next problem onwards. At last EA, two choices are there. Because of you have two S1s. You have chance. Because of two S1s, you have chance. It may be taken some time, but next time onwards, take care. It may be taken some time, but next time onwards, take care. Right? I am repeating once again. This is dangling if-else grammar, which is ambiguous grammar. Next time onwards, take care. In the examination, directly doing this one will take some time. Checking given grammar, ambiguous grammar, not normally everyone know. It is an undecidable problem. Someone is saying that, sir, how to be sure this is a context-free grammar? So there is no relation. See this one. Not LL1, not LL1. To say some grammar is not LL1, there is no requirement of grammar should be, grammar should be CFG and all. There is no relation at all. It is not context-free grammar, no relation. Because of not context-free, it is not. Yeah, is it fine now? Yeah, let's go to next problem. I hope this is fine now. Sure, Satya. I will do that. Yeah, let's go to next problem. Yeah, what about this answer? Consider the grammar rule E goes to E1 minus E2 for arithmetic expressions. The code generated is targeted to a CPU having a single user register. The subtraction operation requires the first operand to be in the register. If E1 and E2 do not have any common sub-expression, in order to get the shortest possible code, what will be the answer? Can you check what will be the answer for this? Try now. What is the answer for this? It is also one of the previous year paper question. Yeah, try this. What is the answer for this? Consider the grammar rule E goes to E1 minus E2 for the arithmetic expression. The code generated is targeted to a CPU having a single user register. The subtraction operation requires the first operand to be in the register. If E1 and E2 do not have any common sub expression, in order to get the shortest possible code, what is the answer for this? Remember only one single, right? Having a single user register. Subtraction operation required the first operand to be in the register. If E1 and E2 do not have any common sub-expression, in order to execute the shortest possible code, let us assume that E1 is a one expression, E2 is a one expression. We have only one register. There is nothing common between E1 and E2. And one more major important thing is the subtraction operation requires the first operand to be in the register. So what you do is first complete the E2 expression do in the register, E2 expression do in the register, then E2 you can store in the, right, then E2 you can store in the temporary variable, right, then E1 will be completed, E1 will be there in the register only. With that one you can do the E1 minus E2. I think E2 should be evaluated first. Answer is B. Answer is B. E2 should be evaluated first. If you evaluate the E1 first, some people are asking, some people may say that, sir, I will complete the E1 first too. If you complete the E1 first too, the problem is, E1 you complete in the register, whatever answer you got, you will store in the temporary variable. Afterwards, you will execute E2 in the register. Again, E2 you have to store in the temporary variable, because to perform the operation, first operand should be there in the register. So you have to take the first operand again back into the register. You first took the operand in the first register, right? You take in the register first two. After completion, you have to store in the temporary. Afterwards, you will do E2 in the temporary in the register. Again, E2 you have to keep in the temporary variable. Again, you have to take E1. Then code becomes a little larger. Best idea is first to do E2, store in temporary. Next to do E1 in the register, already there. Then you can do E1 minus E2. So E2 should be evaluated first, will be the answer. Check once. See, to do the operation, first operand should be in the register. We have only one register. Right? Are you getting? To do the operation, right? First operand should be in the register. If E1, E2 do not have any common sub-expression, in order to get the shortest possible code, then what you do is, first to do E2 in register. See this one. In the register R, do E2. In the register R, do E2. Afterwards, store in temporary variable R. Next one, right? In the register R, do E1. In the register R, do E1. Next one, you can do R minus T1. R minus T1. You can do finally this. Right? First to do E2 in R. Afterwards, T1 is equal to R. Store the R value in the temporary variable. Then R is equal to E1. Then R minus T1. This is the one way. If you do E2, you got how many lines? 4 lines. If you do E1 first, see this one. R is equal to E1. T1 is equal to R. R is equal to E2. T2 is equal to R. Right? Next one. R is equal to T1. Next one. R minus T2. So I think 5 lines. If you do R1 first, then 5 lines required. If you do R2 first, 4 lines required. He is asking shortest possible code. Shortest possible code. Answer is E2 should be evaluated first. Answer is E2 should be evaluated first. He didn't mention, Pratyusha, he didn't mention. Whatever he said, just to do that only. Normally, both should be there in the register. But he didn't say. See, in the problem what he mentioned. The code generated is targeted to a CPU having a single user register. The subtraction operation requires the first operand to be in the register. Second one need not be, because he is nowhere mentioned. If E1 and E2 do not have any common sub-expression, in order to get the shortest possible code, E2 should be evaluated first. Please check whatever is given, just to do that. Normally, to do any operation, both the operand should be there in the register. Normally, but in this problem, it is not required. To do subtraction operation, first operand should be in the register. That is the only thing what he said. Just write which is better for shortest possible code. I think answer is option B. Answer is option B. Yeah, so whatever you don't mention, why we take? Pratyusha, whatever he didn't mention, why we bother? Because he is having, see the line what is given. The code is generated to right? The code is generated is, see, the code generated is targeted to a CPU having a single user register. Means he mentioned already, right? 2 registers are not required. The code generated is targeted to a CPU having single user register. When you say single user register, right? You may having doubt. First operand I will keep in the register or second operand I will keep in the register. He said that first operand should be there in the register. Right? He is using only that CPU having the single user register. Means, right, one register only there. To do any operation, you have only one register. Means if at all 2 operands, one operand only should be there in the register. Second one not required. But which operand? He said first operand should be there in the register. Everything he clarified. He already mentioned the code is generated, right? The code generated is targeted to a CPU having a single user register. It is a nice problem. Please take care. Right? Fine. Next time it will come. Please take care. Next time it will come. Please take care. Now check this also. What will be the answer? Which of the following problems are decidable? Does a given program ever produce an output? If L is context-free language, then L complement is also context-free. If L is regular language, then L complement also regular. If L is recursive language, then L complement also recursive. It is a nice problem. Can you give answer for this? Yeah. So what is the answer you are thinking? Yeah, let me try now. Many people know answer for this. I will check once. Does a given program ever produce an output? Does a given program ever produce an output? It is something like halting problem of your Turing machine. This is something like halting problem of your Turing machine, which is undecidable. Halting problem of your Turing machine is undecidable. So he is asking which is decidable. It is undecidable. So one is undecidable. So because of he is asking decidable, wherever one is there, delete. Answer is either C or D. Let's go to the 2. If L is context free, then L complement also context free. If L is context free, then L complement also context free. No. It may be, may not. Maybe, may not. Maybe, may not. Maybe or may not. Indication that it is undecidable. Indication that undecidable means we cannot say. Indication that undecidable. If L is context free, then L complement is maybe CFG, may not be CFG. Maybe, may not means undecidable. So 2 also undecidable. He is asking decidable. Wherever 2 there, right? Remove it. He is asking decidable. If L is context free, then L complement also context free. Maybe, may not means undecidable. Let's go to the 3. If L is regular, then L complement also regular. Sure. If L is recursive, then L complement also recursive. True. So I think answer is 3, 4. It is a really nice problem. It is a really nice problem. It is a really nice problem. Someone is saying that CFG not closed under complementation. What is the meaning of not closed? Not closed means maybe, may not. I have a CFG. If I do complementation, I may get CFG. I may get more than CFG. No guarantee. When you say not closed, no guarantee. When you say not closed, no guarantee. Closed means guarantee. Not closed means no guarantee. So DCFL, right? DCFL complementation. DCFL complementation. Someone is asking DCFL. DCFL complementation closed. If something is DCFL, DCFL complementation also DCFL. DCFL is closed, means it is a decidable problem. Sir, what is first one, sir, meaning? Does a given program ever produce an output? It is something like, I have a program, I run the program. Right? Will you give guarantee it don't go to infinite loop? I have a program, I run the program. Will you give guarantee it will give the output? It may be, may not. It may go to infinite loop also. Means Turing machine, can you give guarantee Turing machine always halt? Can you give guarantee program will always stop by giving some output? No guarantee. Yeah, first one is halting problem of a Turing machine. Can anyone help you now? In the place of program, they give an algorithm. Does a given algorithm ever produce an output? Does a given algorithm ever produce? Algorithm always stop. Algorithm always stop. Remember, in the place of the program, if they write algorithm always stop. Right? Algorithm never go to infinite loop. Algorithm always stop. Remember, algorithm is nothing but halting Turing machine. Algorithm means halting Turing machine. Program means Turing machine. It may halt, may not halt. Algorithm means halting Turing machine. When you say program, it is just a Turing machine. It may halt, may not halt. Right? It's a nice problem. See, like this only. Questions will be like this only. Questions will be like this only. See, small twists are there. Small twists are there. Please take care. Small twists are there. Please take care. Questions will be like this only. After exam is over, don't say ayyo giyo. Someone is saying, sir, PDA to CFG conversion, how to do? Not required. It is there, right? PDA to CFG there, CFG to PDA also there. It is there, but the GATE examination point of view, not required. It is there, right? You can Google it out, you will get it. The only thing is wasting time only, because in the examination, no one will ask you, right? For the given CFG, convert into PDA. No one will ask you. Conversion, they don't ask. If they ask also, no problem. CFG given, which one of the following PDA? You know, whenever CFG given, find out the language. To that language, you can draw the PDA. Yeah. Not required. So if really required, I could have done. Not required. Manually, you can do. There is no requirement of any procedure. Manually, you can do. But BTech exam, right? Semester exam purpose may be required, but GATE exam purpose not required. Semester exam purpose required. GATE exam purpose not required. Right. Right. Now let me try this also. Let me say something about Unacademy. There is an Unacademy light test series is going on. Unacademy light test series going on. Unacademy light test series going on. Right. So, right, this is framed by top educators. 60 plus tests are available. Right. So 4 months duration, 499 cost. Right. Just see this one. Only 499 rupees. 60 plus tests are available. My suggestion, right, irrespective of whether you are an Unacademy student or not, irrespective of, everyone can join this. Use referral code ReddySir. Irrespective of whether you are an Unacademy or not, right? If you are already an Unacademy student, if you have already subscription, right, I think it is already free. If not, please write it. 60 plus tests are there, 499 rupees. 60 plus tests are there, 499 rupees. Right? Just to use the referral code ReddySir, you can go ahead. Right, next one. See this one. So there is a, right, if at all, if you are a student who is preparing for 2024 GATE exam, if you are preparing for 2024 GATE exam, right? So there is a YouTube session live 14th November 7 p.m. Tomorrow 7 p.m. there is a YouTube session. If your goal is 2024, tomorrow 7 p.m. there is a, right, YouTube session. Right, there all the Unacademy top educators will explain to you what is the procedure, how to follow 2024. Right, how to crack GATE 2024. If anyone interested 2024, those people tomorrow YouTube session, right? So 7 p.m. you can attend for 2024 people. Next one, there is a Unacademy compete, right? There is an Unacademy compete, right? It is a battle and you know where you are. So in this particular app, it is Unacademy compete is there. In this particular app, you can verify yourself comparing with other people. Right? What is your position? You can check. You can check your position comparing with other people. It is recently this is got so many downloads. Many people are interested. You please verify. If you are preparing for GATE 2023 GATE examination, you can verify what is your, right, what is your position comparing with other people. Right? Live on Unacademy Android app. Unacademy Android app, right? It is live. Right? Please take care. Next one. Unacademy Lite, as I mentioned to you, test series, right? You can go for 1 year also, 2 year also. Those people who are preparing for 2024, right? For them it will be useful. For those people, 2023 people, they can take this. 2023 is your goal, you can take this. 4 months, right? Fine. Next one. There is a Vero batch is going on, compiler design. Compiler design is going on 5 p.m. Compiler designing is going on 5 p.m. And one more, this month 24th onwards. This month 24th onwards, Algo also going to be happen. This month 24th onwards, Algo live. And 5 p.m., right? 5 p.m. every day, right? 5 p.m. every day, compiler design is going on. 24th onwards, Algo is going on. And tomorrow morning, right? Computer network crash course is there. Tomorrow morning at 6 a.m. computer network crash course is there. Right? You can attend that also. Use the referral code ReddySir. Use the referral code ReddySir. Next one. So those people who are preparing for 2024, my opinion is start preparation now. If you are preparing for 2024, start preparation now. Through experience, I am saying 2024 is your goal. Start preparing from today. Right? If possible, today only Unacademy. Today only join the Unacademy. Unacademy subscription, 1 year subscription or 1.5 year subscription you can take. 2024 is your goal. Start preparation from today. You can take 1.5 year, right? 1.5 year subscription you can take. Or 2 years also. 2 years or 1.5 year subscription you can take. you can go for iconic because you will get so many advantages. Right? I am repeating once again. If you are serious about 2024 GATE examination, take subscription today. 2 years course or 1.5 years course you can take. You can take the iconic subscription. You will get lot of advantage. Right? Fine. Let's go to next problem. Let's go to next problem. Yeah, this is the next problem. Can you check? Try what will be the answer for this. No, CN crash course on the right, Unacademy Plus. Yeah, can you try this one? Consider the following problems. Consider the following problems. L of G denote the language generated by the grammar G. L of M denote the language accepted by machine M. L of G denote the language generated by a grammar G. L of M denote the language accepted by machine M. Right. 1. For an unrestricted grammar G and a string W, whether W belongs to L of G. He is asking which one of the following statements are correct. Means you have to check every statement. 1, 2, 3, 4. You have to check every statement undecidable or decidable. For an unrestricted grammar G and a string W, whether W belongs to L of G. I think it is a Turing machine membership problem. What is the answer? Undecidable. Turing machine membership problem means W belongs to L of G or not. Membership problem. Undecidable. Next one. Given a Turing machine M, whether L of M is regular or not. Given a Turing machine M, whether L of M is regular or not. Means what you want to say is, right? Given a Turing machine M, right? They will give one Turing machine. The language accepted by Turing machine L of M is regular or not. Right? You cannot say that every Turing machine language is regular. It may be, may not. It is also undecidable. Right? See, every regular will accepted by Turing machine. Every Turing machine language cannot accepted by regular. Maybe, may not. So undecidable. Next one, 3. Given two grammars G1 and G2, whether L of G1 is equal to L of G2. Means two grammars are equal or not. No one knows. Two finite automators are equal or not, I can say. Two DPDAs are equal or not, I can say. Other people I cannot say. Right? Remember everyone. Equality. This is called equality. Equality of finite automata, decidable. Equality of DPDA, decidable. Equality of PDA, undecidable. Equality of LBA, undecidable. Equality of Turing machine is undecidable. It is an equality problem. Directly from the table. Go to the 4. Given an N of A N, whether there is a deterministic PDA P such that N and P accept the same language. It is a very tricky one. Fourth point is very tricky. Can you read once? Given an N of A N, whether there is a deterministic PDA P such that N and P accept the same language. Everyone know N of A N means for every N of A, listen, for every N of A, D of A there. Every N of A, D of A there. D of A is there means DPDA also there. N of A means D of A there. D of A means DPDA also there. Everyone know regular means DCFL also. So, I think two DPDAs are equal or not. Decidable. It is the decidable. Two DPDAs are equal. It is the equality. Equality between two DPDAs. Equality between two DPDAs decidable. It is the decidable. It is a tricky part. Simply table. Mostly I given the right. So in TOC I given one table. Right. Closure property table is there. From that table only all came. Right? From the table only all came. Which one of the following statement is correct? What is the answer? So 1 is undecidable. Only one, only, see this one, only there, only 1 and 2 are undecidable. Only 1 and 2 are undecidable. No, 1, 2, 3 are undecidable. So wrong. Only 2 is undecidable. No. Only 2, 4 are undecidable. No. Only 1, 2, 3 are undecidable. Yes. Answer is D. So Pratisha, CN course is CN crash course is right, revision kind of thing. After CN crash course is over, right? I will take the rank improvement course also. After CN crash course is over, I will take the CN rank improvement course also. This is the crash course. Next, I will take the rank improvement course. It is a really nice problem. Please take care. It is a really nice problem. Please take care. Yeah. What is the answer for this? Let L of R be the language represented by regular expression R. Let L of G is the language generated by a context-free grammar G. Let L of M be the language accepted by Turing machine M. Which one of the following decision problem is undecidable? It is also a nice problem. Can you try this? It is a nice problem. Let L of R be the language represented by a regular expression R. L of G be the language generated by context-free grammar G. L of M be the language accepted by a Turing machine M. Remember, L of M be the language accepted by Turing machine M. L of G is the language accepted by context-free grammar. L of R is the regular expression. Means, I think indirectly, directly, you want to say, one is finite automata, another one is PDA, another one is Turing machine. Right? There are three machines are given indirectly, directly. Finite automata, PDA and Turing machine. Then which one of the following problems are undecidable? 1. Given a regular expression R and a string W, is W belongs to L of R? Means membership problem of regular. Membership problem of regular. Everyone know regular language membership decidable. Next one, given a context-free grammar G, L of G is equal to pi. It is something like emptiness problem of a C of G, decidable. Next one, given a context-free grammar G, L of G is equal to sigma star. It is something like right? CFL, right? CFL completeness problem. CFL completeness problem. If you want to do CFL completeness problem, right? So what you do is given CFL, right? Given PDA, do complementation. Afterwards check empty or not. But unfortunately CFL complementation not closed. So it is also not closed. It is undecidable. Right? If you want to do completeness means everything. Sigma star means what? Completeness, everything. If you want everything, right, whether the given PDA accepting everything or not, if you want to do complementation, right, after complementation if at all empty, then I can say everything. But unfortunately CFG or CFL complementation don't work out. So third one is undecidable. Fourth one, given a Turing machine M string W belongs to L of M. It is the membership problem of Turing machine which is undecidable. It is the membership problem of Turing machine which is undecidable. So what is the answer for this one? They are asking which are undecidable. I think 3, 4 undecidable. 3, 4 undecidable. 3, 4 undecidable. Answer is D. Answer is D. Check one time. Answer D. These only will come. These only will come. Those people who are watching, undecidable problem, these only will come. See, if any tough problem will come, for every person tough. If any tough problem will come, for every person tough. If any tough problem, for every person tough. Answer D. Next one. Consider the following C code. Consider the following, right? Some code is given. They are asking if you create DAG. If you create DAG. Hello? Yeah, if you create DAG, they are asking if you create DAG, how many edges are there? How many, right, vertices are there? The number of nodes in the DAG is. The number of nodes in the DAG is. Right? If any simplification is there, please verify. If simplification is not there, you can do directly. So any two people are same. Can you help me now? Is first line, third line same? Is first line, third line same? Is first line, third line same? Yeah, I think you can do minimization there. First line, right? First line, third line same. You can do minimization there. And one more. Is second line, fourth line same? Is second line, fourth line same? Yes. Second line, fourth line same. I think directly minimization possible. Directly minimization. Can you see this one? This is the direct minimization. VC plus operation. Name is A. VC plus operation. Name is A. Right? Which is also called D. Because both are same. Which is also called D. Next one. A plus 1 is E. A plus 1. A plus 1 is E. This is also called D plus 1 is F. This is F. Because second and fourth same. Means E and F same. Next one. Fifth line. E plus F is equal to G. E plus F. What is the meaning? E and F both are same. E and F both are same is going to be G. I think E plus F. I think plus operator. E also, F also, which is going to be G. Right? So for the G, Left is E, right is F, means both are same. So if you observe clearly, he is asking the number of nodes in that deck. 1, 2, 3, 4, 5, 6. 6 people are there. Answer is 6. Answer 6. Answer is 6. Right, answer is 6. Is it fine? Right, perfect. Yeah, go to the next problem. Try this also. Yeah, let's see this problem. Yeah, I will try this. Which one of the following sets can be recognized by the deterministic finite automation? So something is given 1, 2, 4, 8, 2 power n written in binary. The numbers 1, 2, 4, 2 power n written unary. The set of binary strings in which the number of zeros is same as the number of ones. So remember, finite automata means indirectly is asking regular. Which one of the following is regular? Right, next one. Right, so the set of binary strings in which the number of ones and zeros same or not. I think to this one, everyone know PDA required. So cannot be. Next one, the set 1, 101, 11011, 111011. I think it is something like, careful, it is something like almost 1 power n, 0, 1 power n. It is almost like this, 1 power n, 0, 1 power n. So I think this one you have to check, PDA. It cannot be. Next one, the number 1, 2, 4 and so on 2 power n written in unary, right? The number 1, 2, 4 and so on 2 power n written in binary, right? These numbers in binary format. Let's see this one. 1 means like this. 1, okay. Next one 2, right? Next, well, first one is 1. Next one is 2. 2 means what? Like this. Right? Next one is 4. Next one is 4. Next one is 8. So I think if you observe clearly, listen, if you observe clearly, right, if you observe clearly, this particular automata, if you observe clearly, first one is this. The number 1, 2, 4 written in unary. So unary how to write? Unary how to write? 1, 2, next one 4, next one 8. This is the unary. Yeah, can you help me now? What about option A? What about option A? Can you help me now? What about option A? Yeah, C and D cannot be okay. But what about A? 1, 2, 4, 8, 2 power n written in binary. Written in binary. So how to, if anyone say option A, what will be the finite automata for that? What will be the finite automata for that? What will be the finite automata for that? So is it like this? Is it like this? Someone is saying, is it like this? Yeah, is it true? Is it okay? Can anyone help me now? Is it okay? So 1 possible? Yes. 2 possible? Yes. 4 possible? Yes. 8 possible? Yes. 16 possible? Yes. Exactly. So this cannot be. If you want, you can try. A will be the answer. So this is the diagram. This is the diagram for this. Starting with 1. Answer is starting with 1 followed by any number of zeros. Starting with 1 followed by any number of zeros. Right. So I am stopping here. I am stopping here. I am stopping here. In the tomorrow's class, we will see the remaining problems. In tomorrow's class, we will see the remaining problem. Thank you so much. Right. See you in the next class.